Okay, so welcome again. So this is another problem. So this time we have a tricky problem because on this problem, if you can see, we have four reactions here, and the variation on this problem is that we cannot compute right away for the reaction since there are already three unknowns here. So what we do is to start with the joint where there are only two force members. So that is the key here. Okay, so if we start with H here, it's obvious that we do not have any reference on the forces. Okay, so we cannot proceed with this H. Similar to G, there are two members though, but there is no reference for us to get those unknowns. Actually, there are four here. Two pin connections at G and one reaction at H. Of course, you wanted to check its stability and determinacy by our criterion Truss. We have this criteria, B plus R is to be compared by 2G. So our number of bar, if we counted it, we have 12. And the reaction is obviously 4. And as for the joint, we have 8 joints, so that this will fall under determinate structure or statically determinate structure. So let us now place RH horizontal here, and obviously there will be no vertical for H. That is 0 because we have here a single member, and a single member is countered by an aligned force along its axis. So if that is the case, this is horizontal member, so therefore this should be a horizontal force to counter our force here. For G, we're going to label that as RGY and RGX. So before we'll start with our analysis, perhaps we can observe our truss wherein we look at the axis where there is no forces along its joint. If we take a look at the truss, we have a joint C, E, and F without having any loading. So if that is the case, we can apply the principle of rotated axis along those joints and conclude some zero members. Okay, so determine some zero members. Zero members because if we are going to rotate considering C here, creating an axis on that C, we have X and Y axis, the usual axis, we have no load on this portion. Therefore, along the vertical, there will be no vertical resistance on this joint C. So therefore, we can say that BC is a zero force member. So that is 0. Similarly, on F, creating a rotated axis, say this is X and this is Y, EF and EG are now parallel to each other, so therefore it will just counter each other along this rotated x-axis. However, in Y, there is no Y force along the rotated Y here, so therefore we can say that DF is as well equivalent to a zero force member. So moving on, of course, we are to work with A obviously because obviously A has only two force member to work with, that is AC and AB. So applying now our ruling, we'll just have to go over with joints per joint analysis because this time the loading are oriented perpendicular to a certain member. So this inclined member, say A to G. So considering an X and Y axis on joint A, we illustrate the members one by one and assume a direction for it. Say I will have here AC, that is compression, tensile AB, inclined at 30 degrees, then the 1000 towards the joint that is perpendicular to AB. So remember that between 1000 and AB here, we have a 90-degree angle. So by that principle, we can now determine the angle of 1000 with respect to any angle here. So if we can see here, if this is 30 degrees and this line or y-axis is perpendicular to it, therefore the remaining angle here is 60 degrees and this as well is 30 degrees. It is obvious here that AC has nothing to do with the vertical, so therefore AB is the only force along the vertical line. Therefore, by performing summation forces vertical is equal to 0, we have going upwards, that is denoted by positive, AB sine of 30 less 1000 cosine 30, and these are all equal to 0. So AB is found to be 1732.05. We can get the other force by summation forces X is equal to 0. We have leftwards AC plus rightwards 1000 sine of 30 plus rightwards AB using the angle 30, that is cosine 30. Those are all equal to 0. Therefore AC, substituting the value of AB, we have 2000. Okay, so let us note here that all of our answers are in positive value. So meaning we have correctly assumed the direction for AC and AB. Placing this into our truss diagram, we have 1732.05, that is tensile as assumed here, and a compression 2000 as assumed also here. So all of our assumptions are correct, so we will place it correctly here. Okay, so if we have a negative sign, we will just have to maintain the direction and then just carry the sign on your truss diagram. So if we proceed to joint C, of course, there is no force on the vertical side of C. Then we have a compressive force 2000 on C. Therefore, it will be countered by no other else than CE. And that is also equal to 2000 here. Moving on, at joint B, we will draw the x and y axis. So I'm gonna place here what we have obtained on AB, that is 1732.05, and assume the parallel force, which is BD, and both are inclined at 30-degree angle on the horizontal line. We then again place the 1000 here. 1000 here is again perpendicular to this diagonal member, so that this is 60 degrees and that is also 30 degrees. And then we have here BE inclined at 30-degree angle with the horizontal also. So BC here is equivalent to 0, so we do not have to place it in our fluid body diagram. So working on with the joint B, we take summation forces along Y again. Then we have going downwards BE sine of 30 degrees, going upwards BD sine of 30 degrees, less 1000 cosine 30, less 1732.05 sine of 30. So there are now 4 forces along our equation. So we are going to have that to be equal to 0. Organizing our equation, we'll just have to transpose the constant on the right side and let this be our equation 1. The other equation will be supplemented by summation forces x is equal to 0. So we perform this equation according to the arrangement of this equation. We start with BE. BE is rightward, as well as BD, that is also rightwards, plus a rightwards 1000 sine 30, less a leftwards 1732.05 cosine of 30, and all of this will be equal to 0. Again, we organize the equation. We just have to transpose the constant to the right side, and this will be our second equation. Working with the two equations, we have two equations with two unknowns. We have negative 1154.7 for BE and BD equal to 2309.4. So here we have a wrong assumption because we have an indicated negative sign in our result. So therefore, BE is initially assumed to be tensile. Therefore, with the negative sign here, we'll just have to correct it that this should be equal to positive 1154.7. This is in compression. And then BD yielded to a positive answer. So therefore, our assumption that this is tensile is correct. So we'll just have to place here a tensile force. But in our truss diagram, we do not have to replace the arrow. Okay, just place what you have assumed, then carry the sign and place your BE as it is. That is in tension. However, it is negative 1154.7. So again, I did not replace or change my assumption for that BE. So it is assumed as a tensile, but I'll just carry the negative sign for that. So moving on with the solution, of course, between D and E, D will be much preferred because at D, there are only two unknowns, namely DG and DE. So we isolate joint D here. We see at joint D, have the X and Y axis. Illustrate what's in the joint. So we have here 2309.4 inclined with the horizontal line at 30 degrees. Parallel to it is DE assumed as you see. We again use the horizontal line for its reference angle 30 degrees. We reflect the 1000 force perpendicular to these inclined members. So those are the internal angles using this figure. Now for member DE. Member DE is just vertical. Why? Because as we can see in the figure, we can conclude that the last angle here is actually 60 degree. Therefore, this is the force assumed at a tensile orientation. So, working with this joint D now, we form summation forces X is equal to 0. DE cosine 30 degrees. We think we have a similar force here, so perhaps you can check that one. So joint D, this is DE. This is DE. This should be DG. Okay, so that this is also DG. Okay. Less a leftward force 2309 cosine 30 plus the rightward 1000 sine of 30 degrees. And these are all equal to 0. So here we have a single unknown, DG to be equal to 1499.65. For the other unknown, we perform summation forces Y so that we have downwards DE, downwards 1000 cosine 30, downwards 2309.4 sine of 30, and an upwards DG sine of 30, that is equal to 0. We substitute the value of DG So I think we have to check for DG here. We should have 1732.05. Substitute it in here. We have negative 1154.7, which implied a wrong assumption on the direction. So looking on what we have finished, we can place here now the value for DG, and DG was assumed to be tensile. So here is DG, that should be tensile with a value of 1732.05. And as for DE, DE yielded a negative answer, and it is assumed to be tensile also. Therefore, we'll just maintain that tensile, but to maintain also the negative sign. So finally, as we can see here, we will now proceed to joint E. So looking at what we have finished here, we have already indicated the forces on the truss diagram, and then what is left is the member EH and at joint G. So if we consider joint G here, there will be three unknowns, namely DG, RGY, and RGX, aside from FG here, which could be determined out of the joint E. So it is more feasible that we will work with joint E here. So since joint E contains EH and EF unknowns, so we isolate joint E. We have an upward force DE. Don't forget to carry the sign, and then indicate this negative 1154.7 inclined at 30 degrees and rightwards 2000 here. We assume direction for EH, and this is EF inclined at 60 degrees with the horizontal. We perform summation forces x and y is equal to 0. We have this rightward 2000 here, this leftwards 1154 here, but carry the sign. EF towards right, that is positive. EH towards left, that is equal to 0. So we leave this for a while, tagging it as equation 1. And then we perform summation forces y is equal to 0. The upward force here, 1154, but carry the sign again. And another upward force, carry the sign again. The EF going upwards, sine of 60. These are all equal to 0. We have EF is equal to positive 2000. We go back to equation 1, substitute here, and then solve for EH. We have EH be equal to 4000 positive, which is also equal to the reaction at H, 4000. So we place our answer to the truss diagram. We have EF, this is EF, okay, EF, and EF is assumed in your joint to be tensile, so it is tensile in your truss diagram. We'll just adapt that one and then place their EF equivalent to 2000, and therefore by looking at F, say this is our F, can also say that this is 2000 as well. So finally, proceeding to joint G, we have the x and y axis. Place the two reactions. We place the external 1000 here perpendicular to this member, and this is inclined at 30 degrees with a vertical line. We place 1732.05 for DG. And this is inclined at 30 degrees with the horizontal line again. Then we place the tensile 2000 here, inclined at 30 degrees with the vertical. Why is it that it is 30 degrees inclined with the vertical? Because as we can see, this is actually the slope of that one, okay? And the slope is 60 degrees with the horizontal line. So if this is the horizontal line, okay, so we're going to measure 60 degrees, okay, and the supplementary angle of the 60 would be 30 degrees, referring to the vertical line. Then by this function, we write the equation. We add the rightward force 1000 sine 30, and then we deduct the leftward force 1732.05 cosine of 30. We deduct this leftward force 2000 sine of 30, and these are all equal to 0. So we have an RGX equal to positive 2000. So moving on, we take summation forces vertical. We have here the downward 1000 cosine 30, the downwards 1732.05, and then the downwards 2000 times cosine 30 plus RGY is equal to 0. Solving now for RGY, RGY is 3464.1. So again, we place these results into our truss diagram. See, RGX is 2000 and RGY is 3464.1. So out of the internal forces from the truss, we arrive at the three reactions here: RGX, RGY, and RH. So what will be our check mechanism here? Of course, we're gonna use this as our check mechanism. How? Let us put in place the resultant of this 4, and the resultant of that 4 is equal to 4000, or 4 times 1000. We get the component by using this angle, 30 degrees. So this horizontal is equal to 2000, and this vertical component is 3464.1. Now, comparing this to what we have got in the reactions, on the vertical we have a downwards 3464.1, and among this reaction there is only an upward 3464.1 that will counter this one. So therefore we are balanced in terms of summation forces vertical. And for the summation forces horizontal, we use the horizontal component of 4000, that is 2000. So a rightward 2000 here, and another rightward 2000 will yield a total of 4000 along the right side. And this shall be countered by the horizontal leftward force that we have computed on the reaction at H. So that will be our check mechanism. But if ever that this will not yield to 0 along X and Y axis, then there are some mistakes along your solutions. So perhaps you can go back one by one to your solution. Okay, so that's it for this problem.